Hello, my name is Daniela Lobin, and today we will be talking about nuclear chemistry. So when we're looking at nuclear chemistry, we're going to dive into the types of radioactive decay. We have alpha, beta, and gamma emissions. So when it comes to alpha, that is the nucleus of helium, and it has an atomic number of 2 and a mass of 4. And it is usually represented in alpha emissions. We also have beta, which is similar to electrons but not quite the same, and it has a negative value, which means that it will help to increase the atomic number under beta decay. And then we also have positrons. Positrons are basically positively charged electrons, and when that's added and there's positron decay, that means that the atomic number will be decreased, but the mass doesn't change. And same for beta, it does not change as well. Gamma rays are very radioactive, and it helps with the stability of different elements. So once gamma rays are created there, it allows a value to be stable and then be able to react positively. Then we also have neutrons, which makes things more unstable because it is highly radioactive. And neutrons can be represented as 1, 0, and then an N. Then we also move into half-lives. Half-lives really just help us to determine how long it takes for half of a radioactivity particle to decay. And the equation for it is NT equals N, which is the initial time, times 1/2 N. And N equals the total amount of time divided by the half-life. We'll also talk about how radiation exposure is measured in sievert, and that once electrons are moved and the cell becomes destroyed, that's what actually causes cancer. And when we're looking at the biological effects of emissions, we know that alpha can be stopped by the hand, beta, aluminum, gamma, lead sheets, and neutrons stop at concrete. And we also know that when it comes to cancer cells, tracers have minimum radioisotopes and minimum radioactive exposure, whereas mediums are a threat, kind of like help to treat the cancer cells and really bring back the organization throughout the cells. And then high amounts of radiation actually causes cancer, and a way to treat cancer can be through iodine-131. So that's pretty much all for nuclear chemistry. I feel like this is one of my strongest chapters that I know and can really understand it and explain it to other people. Thank you.